we're going to see the variation of the definition of covariance so that we can be more close to covariance, and actually it's more useful when we have to deal with covariance. So let's take a look. So in the previous video, I introduced the definition of covariance is summation of x minus x bar times y minus y bar and divided by n minus 1 when it's simple. But we can actually express it in this, it's the same but in other way. So expectation, this is actually expectation form. So x minus x bar and y minus y bar. Like, yeah, for me is this process feels very comfortable. So okay, so let's keep going with this one so that we can get more convenient form of covariance. So here's something we can do that we can actually we don't like this kind of form, so we want to disorganize it. I'm not sure disorganize the right vocabulary here, but okay, you know what I mean. So let's keep going. So x times y and minus x times y bar here, minus x bar y, and it'll be plus x bar and y bar. And in the very I think the first two videos of this channel, we dealt with the concept of the linearity of expectation, and we learned that it works anytime in any condition. So we're very comfortable with using the concept of the linearity of expectation here. So it would be the expectation of xy and expectation x times xy bar, expectation x bar times y. Let me just keep going here. Expectation of x bar, y bar. And we know that x bar and y bar are actually constant here. We're talking about a certain sample. So we know that we already have the actual data of x and y, so we can get x bar and y bar, which are x mean and y mean. So they're constant. So it can be confusing because we talked about the concept of variable of x bar and y bar, not y bar, especially x bar. But in this case, we're talking about one sample. So anyway, yeah, it's a constant that we're familiar to. So we know that when it's constant, we can take it out from the expectation form. So expectation x times y, and y bar is constant. So y and expectation x, and here x bar is constant, so x bar times expectation y, and it would be just constant. So expectation of a constant is the constant itself, so it would be just x bar y bar. Yeah, so when we look at this, we know that this is x bar and this is y bar. So we can rewrite this as expectation x times y minus x bar y bar, also minus x bar y bar, and plus x bar y bar. Right, and we have 3x bar y bar. So we can do this, and as a result, we get expectation x times y minus x bar y bar, which would be expectation x times y minus expectation x and expectation y. So this is like the variation of covariance. So yeah, there's nothing wrong when we use this form or this form, but actually it looks way uh, familiar, not familiar, but like kind and actually like easier approach. So most of the time we will have information of maybe expectation X, expectation Y. So all we have to do to get the covariance of X and Y would be getting expectation X times Y. But in this kind of form, it's kind of like not very clear, and I don't have any idea what to do. So yeah, this is why we change it, and we're gonna take a look with the concept of independence in this form of covariance. So okay, so thank you for watching, and hope you guys had a nice day. Thank you.